Wow. All right. So this is actually one long section, and it's something I'll talk to the program committee next time to say, okay, when we do these back to back, where it's actually one long section, we'll figure out how to do something with it. So you guys are all coming into it's a service bar security toolkit approach. So this is a security-oriented session. And I'll walk through just as a review so people will get an idea of what we're talking about here. So how many people here, just count of hands, how many people are brand new now? New people. We got some, yay. Good, this is good. We've got a lot of new people. We're trying to get more and more new people coming in on. My name is Barry Green. I've been around in the community for a long, long time. My background goes where I started on the ARPANET, or actually the DVN network when I was in the Air Force in the 80s. Got out of the Air Force in '89, and my next door neighbor says, why don't you come over and keep on working on the internet thing? And then I kept on working at the internet thing as a temporary job for quite a while, and then it kind of grew and grew and grew and grew. I was fortunate, I've been lucky. Got to work at some good research labs, really good people over the years. Got to build service spotter in Southeast Asia, Singular Telecom. Worked for 12 years at Cisco Systems. I was the chief service spotter security architect guy. Worked on technology, NetLoad, and Cache RTF, things like that. These technologies to work with. Went to Juniper. Was the director of the security incident response team over there for 3 years. Great place. You know, I love the open source code and the Junos code and things like that with it. And now I'm working for Internet Systems Consortium. Went there originally to do security work, to do what I'm doing now, but I had to delay the year because Paul Vixie and I, if you know Paul Vixie and DNS and things like that, that's ISC, he and I swapped roles, so I'm now president, and so I had to help invest in making sure ISC is a nice, stable, sound position, which we are. And now we're doing all sorts of different projects. So ISC would do things you know is combined. And this, we're doing here is curriculum around service fire security, which we're building up. We were asked to do, my colleague who was just here, Medica Kale, blonde in here, she just left. So you're thinking, where is she at?
I know her for years.
Yes. Yeah, so she's around, so she'll be at the after parties tonight and stuff like that, so check. She was the one who taught me how to do access lists to protect routers years ago. You know, how do I protect my network? You know, and I called Cisco, and she was the one I called at Cisco and said, here's how you protect the network. So she started teaching me network security on routers years ago. What we covered already, we covered threat vectors, we covered why security is important. We covered where all of you who are not doing security in your backbones today are probably going to be in a situation quite soon where your boss is going to say, we have to do something. So you're jumping right in the middle of the session. I'm going to be going through a talk, kind of like why I think the world was going to really change in 2012 to give you some context, so I'll fill in some of the blanks for you to catch up. And then we're going to swap over to sinkholes. So I'll talk a little, so you just missed the section on remote trigger black holes and source-based remote trigger black holes. Don't worry, because this is taped, and there's a history of these taped sessions on it. And if you're really interested in any of this stuff, as I open it up, I'm recruiting people. So any of you who have things on your networking, you're interested in deploying any security technique, you can come and talk to me, and we'll help and work with you. Any of you who are exploring interest in security problems, you're looking for advice, come talk to me, right? And we'll work with you. The materials that I'm presenting here are all open, right? So in other words, I'll point out here in a few minutes, the URL basically is confluence.isc.org. You go to that site, you look for the space, for Confluence space, for SP security, and all the PowerPoints are going to be there. I'll load up the PDFs later on. So those of you who are like anti-Microsoft, I'll load up the PDFs. But put the source there. So any of the stuff you see out here, if you say, hey, I like the slide that Barry did, I want to use that to convince my boss that we should do this technique. Take the slide, pull it into your slide presentation, and you can look really good in front of your boss, to convince them that we need to do this technique. Sometimes I tell people that the best thing that I can do for the industry is I create PowerPoint slides for very brilliant engineers who can't do PowerPoint slides. And it works quite effectively with that. So, anytime, ask questions with it, and so we'll try to catch up everybody who's new. So, now, one of the things you missed is I walked through a whole scenario talking about how the bad guys go out there and basically they can own our networks. We're living in a situation right now which is a lot of people are pessimistic because the antivirus doesn't work anymore like we think it's going to work. The operating systems, even though you got brand new operating systems that are doing security development lifecycle, they're still getting broken into. Macs are now getting targeted by criminals because there's a lot of money behind it. There's a lot of money for criminals to make a lot of money off of it, and they're going after targeted systems. Everybody here in this room, I can tell you right now, probably have systems that are infected, and you probably don't know about it, or you may know about it and you don't know what to do about it. They get infected all the time with it. That's just the way the ecosystem works. But as I was asked to do several weeks ago at this conference that had a whole bunch of law enforcement people, the Internet Crimes Consortium meeting in Fordham University in New York, they asked me to do a keynote and say, what do I think the future is going to look like? 2012, I think, is an inflection point. I'm going to talk about why, and talk about some of the community, and talk about why you here is one of the reasons why I think 2012 is going to be, when we look back 10 years from now, is a year where things start turning around, we start pushing against the criminals, and really protect our infrastructure. So the key thing is private industry. Here in this room at this conference, because of simple things as, I'm here on the badge, it's not black. I got to complain to NANOG that. It's supposed to be black dot. But there's a blue dot, right? So those of you who are new to NANOG, you go up to the side, you go up to the front there, registration, and there's these 3 dots. And these are important because we glue the internet together with people. It's all of us here who figure out how to interconnect and work with each other. That's why you come here. It's not just attend these sessions. I tell people they come to NANOG, so I'm going to hear sessions. I said, no. You don't go to NANOG to watch sessions. It's all taped. You can watch the sessions online. You come to NANOG to meet your peers. These are tools. The blue dot for this side is security. So those of you who are interested in security, you hear my talk, you're trying to find other people and other peers, get the dot on your badge. If you see somebody who says, Eddie here, says, okay, Eddie's in Clearwater. Hey, I've met Eddie. Right, he's a security guy. We got to exchange cards. So now I'm the Clearwater guy. So I got to get his card and say, and do something as simple as say, okay, so I know where you are, right? So I got a security guy now. This is now the green dot, BGP parent, right? I now work for 1280 ISE. We want to peer with you, right? Come peer with us, right? Keith Mitchell, who runs my network engineering. He's running around, he's got just the green dot that says peer. The red dot, BGP key. Because sometimes we have to do security stuff where we have to go encrypted, right? So if you want to sit down and we do key exchange, let's do key exchange and sign each other's keys, right? This right here is critical, and this is what we talk about in the private industry, really doing a turnaround in industry because of things that happens here at NANOG where we, as peers, get to know each other and start working with each other. This has been going on for over a decade now from a network security standpoint. It's been making now big differences. We are now coordinating and collaborating with each other on the industry in a way never before. The domain change or collaboration, which is a whole bunch of service providers working together on this particular piece of malware and taking it down, is a big industry collaboration. 10 years ago, we wanted to have that sort of collaboration. Today, we're having that collaboration with the FBI and knocking down a gang in Estonia who ran a whole colo operation. They had whole offices and everything. Rogue Digital was like any other colo. But the whole operation was set up for doing criminal activities. Right? And that was an industry effort to take it down. So this is the sort of thing that's changing things around. When you meet each other, we start working with each other, we start creating group, of course, let's start creating mail lists. All right? And I'll talk a bit about this with the operational security community, where these groups start getting together and we start specializing. 10 years ago, when we started first doing how to protect our backbones, back in 2000, everything was all on one list. Now we specialize. Like for instance, NSPSec talks about backbone security. YASML, II are groups that focus on, let's take the piece of malware, new piece of malware comes across, and anybody who does malware research is on that list, and they start ripping the malware apart and figure out what that malware does. What are the bad guys doing with it? Okay? The DNS org, protect DNS. Anything that happens to DNS, that's a community takes that. X domains. Here's a domain that the bad guy is using. Let's get it removed from all the registrars and registries. That takes care of that. All right? So we specialize across here, right? And there's this group, OPSEC Trust, that actually is a kind of like a Facebook for the good guys, where we can actually create teams to investigate Torpid and Zeus, and name an hour, and there's some team working on it within the private industry to investigate what's going on with it. We can do it with encrypted wikis, exchange tools, with information being shared that flip people out. Saying, I didn't know you guys shared this level of details of information of each other's, what's going on in each other's networks. What that's having an impact with is it's allowing us to actually make big differences. And these big differences is why I think that this is going to be a turnaround year. And all of you guys are part of this, where there's a strategy of the action, because all these different hours that we're actually making a success with is making a difference. So one, this private-private collaboration going on here is increasing. In other words, everybody here is public-private partnership. Public-private partnership. You hear these policymakers, we need public-private partnership. That doesn't really work. What works is what's going on in here. This is private-private collaboration. This works. All right? Eddie and I met each other. Something happens on his network. He calls me up, hey, I need some help. Hey, let's work with each other. Let's get that network back up and running. That's private-private collaboration. That works. All right? Then, if we need law enforcement, say, hey, whoever did this to your network, Eddie, let's go after them. Hey, let's call a law enforcement buddy. Let's call somebody at FBI. Let's go after these guys. Then you start working with the public sector. All right? And this model is the model that's now, really pushing out in all parts of the world, and it's having a difference with the work with it. So these activities, is really making a big difference. The technologies we talked about in this session, the one we talked about before this, the ones we'll talk about here in a minute, are really panning out and making a difference. In other words, it's not one of those things to say, I can't do anything to protect my network. We know what to do to protect networks. And they're not hard, and they're not expensive. Like, for instance, just before this, we talked about remote trigger black hole. Okay? Now, those of you here in the first session, how much do you think it costs to do remote trigger black hole and deploy it across your network? Okay, let's see. Well, step one, let me configure static routes on all my routers. Okay, how much does that cost you? I configure static routes on all my routers. Okay, there's no capital cost there. All right, step two, I have to configure a trigger router. That could be a spare router, it could be Quagga, or I can use an existing router on my network. How much that cost you? Not much, all right? And if I want to configure it for routing traffic into a sinkhole, what's that cost? Probably spare gear. In other words, the techniques that we use to actually lock down and secure a network are not capital intensive, but they work. They work quite well in helping to protect the networks and preparing a toolkit with it. So it's not a matter of we don't have tools. We have the tools for detecting, for tracking, and mitigating what's going on with the bad guys. Right? How many people here get reports from different agencies on how many infections on your network? Anybody get reports from people? Team Cumry, Shadow Server, groups like that. We'll talk about that. You can get these reports. They don't cost you anything. Shadow Server, vShield will send you reports. No cost. We know what computers on your work are getting affected because people are watching and monitoring. They'll send you a list for free, right? So the existing technologies for remediation have also, we'll talk about here towards the end, how do we remediate off of a network. In other words, when your customers get affected, how we clean it up. Then action. So when you guys, anybody here, if your network is attacked, you guys do anything outside of protecting the network? In other words, one of the things we're asking people to do is not just, let me protect my network, but actually do something beyond it, like work with your peers, push against the malware, attack the malware, like take it down. Attacking the malware is like, here's a botnet controller, find a botnet controller, and then remove the botnet controller from the net. This sort of action actually makes a big difference. If somebody touches your network and attacks your network, attacks your customers, then sitting there and just responding to it, those days are actually aggravating. And it makes it even more so with the guys like Anonymous. Guys like Anonymous, if you just let them hit you and you don't kind of like dismantle their infrastructure, they'll hit you again and hit you again. They'll get bold with it. Effective collaboration, I'll dive into this in a session on what the OPSEC trust and groups like that with it, but this is going to have a big impact with it. And then this is something that, thanks to Microsoft, is really panning out in a very interesting way. There were several of us a couple of years ago who said, if somebody touches my network, instead of just allowing them, just to run rampant with that particular piece of malware, let's do something about it, not with the law enforcement agencies, but in the civil courts. In other words, if I have lawyers working for me, and those lawyers know how to litigate, take something to court, and I can identify, say, here's an asset. So I say, okay, here's a computer asset. This is a computer asset. It's being used for malware, right? And with that malware, it's in some hosting center. So let's say, I don't want to pick on you, but say it's in your hosting center. He's a roll-up player, so let's say it's a hosting center, right? And instead of just saying, hey, can you take it down, right? And then the guy would go away. Instead, I say, okay, let me go to court and say, here's all these computers in his hosting center, his hosting center, his hosting center, his hosting center. Here's all the computers. And you go to court and say, these computers are part of a criminal ring, and they're being controlled by John Doe. I don't know who John Doe is, but they're being controlled by John Doe. And we want to confiscate all of these because all these computers together has caused my network damage. Here's how much damage it's causing. So I'm suing John Doe. I'm suing John Doe for damages because John Doe has caused my network damage. Right? And here's all his assets. Okay? And until John Doe comes forward, I want to confiscate his assets. Right?
What about the case where those are owned by a hosting provider?
If they're owned by a hosting provider has to say either they've been violated and then they have to clean it up, or if the bad guy buys it, because a lot of times that bad guy buys it, then the hosting provider has to give up the account. So it's now the account, instead of owned by John Doe, the account is now owned by me, that I just sued. So now I have access to that computer. I have access to all the forensics information. Right? This is exactly what Microsoft did with Walladac. Right? They went to a hosting provider and said, here's my court order. The court judge says, yes, here's the court order. Walks in the hosting provider, says, this computer that's been violated, I now own until John Doe shows up. Now, of course, John Doe, is he going to show up and walk into U.S. soil and show up and say, hey, Microsoft can't steal my computer. I paid for that computer. Microsoft says, oh, sure, good. Let's take you to court, right? Let's take your passport away. Your flight risk now, right? That sort of thing going on with it. So this sort of civil action is Microsoft started this, and we're going to be trying to get other companies to do the same sort of thing with it. And what that will do is cause a really pain in the butt for cyber criminals. Very interesting sort of stuff with it. So some of the case studies see on Microsoft with it. The other thing, and Sandy's not here, but Sandy just asked me about AS path filtering. I don't know if you guys knew this, but you will know this later on in the year when we start writing up the papers. Here's how you can take BGP and have total control of who you talk to on the net. So if there's some hosting provider sitting in some country out there, and it's a source of spam, and the spam is coming on your network, and the spam costs you money, because that spam comes in there, you have to process it and drop it. You have to spend resources and computer capacity to filter that spam. So it costs you money. And you can say, I don't want this traffic. I wish this traffic would go away. It's all coming from this particular colo on this particular autonomous system number. I wish I could just filter it. Well, guess what? You can filter it. BGP allows me to pull out and not have anything coming to it from that particular autonomous system. You can filter it based off the autonomous system. capabilities in Juniper and Cisco routers to do that. You have, as an autonomous system yourself, control over, I don't want to talk to, you're the bad guy, AS, I don't want to talk to you at all. Even though you're 4 hops away in the AS path, I can still set up my BGP expressions, whether it's a Cisco, Juniper, or Lucent Alcatel, right? I can set up those filters to do that. We're going to be teaching people how to do that this year. In other words, part of this materials that we're resuscitating here with this session and further sessions, you can probably see, if not next now, then the NANOG after that, we'll have a session in a regular NANOG session. Here's how you actually protect yourself with the filter techniques. Here's the different configurations of different vendors. Here's how they work. Here's a lab how to do this. And then you have another tool in your toolkit and say, here's a service provider in Turkey or Romania or in Vietnam, and they're colo taken over by bad guys, and I don't want to talk to them anymore, and you can filter. That's going to cause a monkey wrench with bad guys. So in other words, all these things add up where we can go through and push against it. Real-time forensics data sharing. This is one of the projects that IAC works on, where we're able to take like the DNS changer, which you'll hear about in a couple of sessions this week in the lightning talk. That we were able to go through and take over the bad guy, the Road Digital DNS servers, and put our servers there, so we put clean DNS servers, and then set up the filters and have the actual list of here's who's like infected, because they're all coming to those DNS servers, and feed that out. In other words, it comes in from a particular, in this case it wasn't a sinkhole, it was coming into, from the DNS servers, into a SIE exchange, and then out where Shadow Server in Hungary and a whole bunch of organizations got the feed within minutes. As soon as the feed went in there, it was flooded out. So in other words, we've figured out how to actually peer with each other with security data sets, where we're peering with each other with passive DNS data sets and malware data sets, right? And basically share this information so we get a collective vision, a collective view of what's happening to bad guys. All right, because if you have a view of the bad guys, you have a view of the bad guys, you have a view of the bad guys, it's a fragmented data set. We all put it together where we can share with each other and peer with each other. Now all 3 of you have a better idea what the bad guy is doing. And we have an idea what the bad guys are doing, and we go out there and do something about it. Whether it's, you know, filtering them, stopping them, pulling out their infrastructure, or in large cases, putting handcuffs on them, working with law enforcement, putting handcuffs on them, right? Probably the most impactful thing happening this year, and this is why I think these sessions and why I'm kind of starting resuscitating these materials again, is 2012 is going to be the year where we're going to have more of the quantification of the risk. Behind the scenes for years, a year and a half ago, we took down this game that was used in Zeus. It was a variant game called Zeus Petrovich game. Zeus Petrovich per week, we're tracking $15 to $20 million of theft per week. The game was in operation for over a year. $15 to $20 million of theft out of personal bank accounts. This is one game with one cyber criminal cloud infrastructure. So behind the scenes, when you get in and start doing the investigation and seeing the money being stolen, the loss in civic society being happened, and these guys are smart. I gave an example of how smart they were. Like, these guys would figure out the acceptable loss thresholds and where the trigger points were. So there was a case I gave in the last session where my wife's credit card got hit by a card group. This card group would basically, it's a secret shopper group, and say, okay, they stole my wife's credit card, and they say, okay, here, you're a teenager, and this is a crew in Miami, and here's your white credit card, which is my wife's credit card, and here's the shopping list, and you're going around the stores you buy with that credit card, okay? And the shopping list had to be exact. It tells you exactly which merchandise to buy. Because what you would do is you would then bring all the merchandise back to me, and I'd give you a cut of the money. So I'd pay you $200 to do that for the day, and I take all the merchandise and send it over to a shipper. The shipper sends it to Nigeria, and Nigeria then sells on the back market, and there's this whole scheme that goes on. But the hit was $4,999 exactly. It was a Chase card, and Chase at the time only clocks down the card at $5,000 of theft. Okay? The stores that were hit were 6 different stores with 6 different insurance agents. and this is what's key, this is something I didn't tell last time. The other thing I found in that investigation, 6 different insurance agents. That means what they were doing is the criminals were spreading out the risk across the insurance agents. So the insurance agents couldn't total up the total amount of crime happening. What's happened with this one survey that Norton put together, Samantha Norton, when they did a survey, they started figuring out how much crime. When they're talking about, $200 billion of crime or cybercrime, when we're in that much range and they're starting to count it, then insurance agencies, your insurance agencies, start waking up because, wait a minute, we're insuring these networks. And this is how much stuff is out there, things start kicking in. In other words, the capitalism has a risk system set up, right? And that risk system is a carefully balanced system to balance out the risk. And certain forces right now, they couldn't count the cybercrime back to the society. This year is the year where we start really counting in a granular way, in a public way. And what that's going to do is that's, a year from now, you're going to have your bosses come down and say, so what are we doing about security? So, well, why are you asking? They were asking before. Says, well, the insurance agents wants a report. Otherwise, they're not going to insure us. What are we doing about security? All right? And that's part of putting these materials together so that way you can go back to them and says, well, here's all the things we're doing to reduce the risk for our network with it. Another thing we're doing is taking back DNS. Did you know, guys, the bad guys hide behind DNS? Just hide behind it because they can lock down the zone files. So I go out there and get a whole bunch of DNS names and just hide behind it. So what you guys get is you get an email coming in your spam, and I got a domain name. It's a really strange domain name from Romania or something. And you know that tomorrow he'll use a different domain name. I wish I knew what that domain name would be tomorrow. Well, did you know we can actually find that domain name path? All right, we're taking back DNS with passive DNS. Right. So this is something. There was a lightning talk I did 2 nanogs ago. We'll do a lightning talk on the next nanog. And this is a tool that everybody here who is an operator, if you're looking for a forensics tool so you can see what's going on behind the bad guys, come see me. You have authorization where we can get you a passive DNS account. You can check that out, and you can see, wow, I can start seeing it. And if you're interested in feeding this passive DNS data into the community, it basically allows us to go through and say one domain name and see exactly what they're doing. We can rebuild zone files. Take one domain name that the guy is using, and you can go to the name server and figure out every single one that's going on in there. So you basically, Spamhaus and Servo is getting richer lists, and they're black holing whole ranges of domains that the criminals haven't used yet. We're taking back the DNS from the bad guys where they can't use it like they're using it right now to just go out there and do their crime. So all these sort of things kind of build up a positive approach. There's a lot of pessimism that we've had over the last couple of years. Cyber criminal crime has been growing. But what we're seeing is this year is going to probably be one of the watershed years where we're turning things around with it. DNS Changer is probably one of those core things with it. So how many people here have heard DNS Changer? Know what it is? Okay, this is pretty, there'll be a lightning talk on it. DNS Changer. This was a criminal gang that basically Rogue Digital was a colo in Estonia. Their criminal operandi is to get malware onto a computer and they take control of their DNS. So in other words, instead of having the customer or the end user go to the regular service provider DNS servers, they went to their DNS servers. So then when they go out there and somebody browses and goes like to Amazon, they would do ad insertions and basically it would set up a man in the middle and then put, criminal ads and malware advertisements and things like that into it. Yes?
Was that DNS Changer, was that the one that caused the Department of Justice to send out that totally bizarre email that made no sense?
That's the one.
Okay.
It was a big embarrassment for the FBI because the FBI is running with it. Yes, that's the one in the NANOG discussion that was from that, the victim notification letter.
Yeah.
That used the wrong data set.
Okay.
Because what they used is they used a wiretap that they did off of a VPN when they got the VPN for the entire colo versus just what was going on with the DNS stuff. And so they were sending letters out to some, it was, okay. FBI admit that was a mistake. And they're learning from it, right? But it was actually a big industry collaboration that allowed this to happen. So things that there'll be more like that. We're having good successful takedowns. The key thing with that one is that colo is shut down, and the people are all in jail, right? And they will be prosecuted and be moved over here to the United States and prosecuted in the United States, right? So we're able to actually trace things back down when you talk about how do we do international criminal prosecution. We're learning how to do international criminal prosecution. So while that Rogue Digital, the domain changer, the FBI victim notification letter was all screwed up, we still got handcuffs on people, and they will be prosecuted, right? So this is where the action part comes in. We are learning how to do this, right? But it starts here with private industry. So let me pop up, get my next section here. And what I'm going to do since we have so many new people, and this would be, sorry for the guys who were here at the first session, I'm going to do a quick run through so we'll put this in context before I do sinkholes. All right. So over time, since the year 2000, when the service provider community started getting together and says we had to figure out how to protect ourselves, right? Certain techniques, like a toolkit of techniques approach. So the approach we use to protect our backbones is not to say that there's one solution to do it, because there is no one solution. And the range of backbones we have in here is everything from cloud providers to big banks to service providers that are residential oriented to cell phone providers. We have a whole range of networks. So no one tool is going to protect everybody. And we as engineers have to do engineering. We have to engineer our networks, right? So we take these toolkits and we apply it inside our engineering network. So these techniques, and I'll walk through these, right? First thing we got to do is preparation. We got to prepare our network operations center. We got to do what you guys are doing here right now is prepare, right? You can't wait until, pardon the English, shit hits the fan and then start preparation. It's too late then, right? So planning ahead of time and doing something. And you'd be amazed how a little bit goes a long way. So that's the first phase we talk about of the principles. Second thing is the collaboration. I talked about it here with the dot on the badge and getting to know people. This is probably the most powerful technique where you get to know your peers and work with your peers. You'd be amazed how many times the internet has been saved because a whole bunch of competitors got together on a conference call and started working with each other to save the net. Right? Really, really critical to get to work with your peers with it. And then come up with tools with it to do it, whether it's private lists, offset trust portals, INOC-DBA, you invest in your peer connections. Right? Come into NANOG. Come into right. Right? Your bosses are saying, well, why am I going? Why should you go? I mean, how many people here had to really argue with your boss to come here? Right? Hands come up, right? You got to tell your boss that says, if we don't come here and we don't invest in your peers, then something can happen in the network, and I'm not going to know the right people to call to actually keep our network up and running. And that is a true statement. That's a true statement. There's a lot of times that's happened with us. You got to invest in it. You got to work on your own network to make sure your network is locked down and protected. And some of the techniques to do this are not hard, are not complicated. The example I gave in the last session was a tool that CNN used back in the year 2000, which is take VTY access list and put log files on it, and you put it into syslog. So then you take all my router devices, all my switch devices, and I take the VTY access list. So if I get the scans, I log the scans in syslog. And then what they did in 2000 is they put it into MRTG and had a graph. So every day they got to see across the network all the scans hitting their port, right? And they got a threshold. And every day they had a threshold. And then a month before the elections in 2000, it spiked up really high, which told them that somebody's really paying attention to my network. Maybe we should prepare. We're probably going to get attacked in the elections. And they prepared. And they were able to keep the network up and running. CNN kept the network up and running because they saw that they were going to get attacked. Now, what did that cost them? VTY access list, syslog, which you were doing anyways, put a script in the syslog, throw it in MRTG. The only capital cost was spare servers that they used to process the MRTG and produce the graph. right? So some of the techniques we use to protect ourselves are not expensive techniques to do, all right? Same thing with edge protection. Edge protection is a core principle, right? And edge protection ranges, right? It could be everything from using BGP to filter, could be using the IGP separation. There's a reason why there's a lot of backbones out there use ISs or IGP from a security standpoint, because it is not IP, right? So you have BGP, which is IP, and you have IS, which is not IP, and it's a way of actually keeping ships in the night and keeping two protocols for doing, that's part of edge protection. And some people, wait a minute, I'm talking about my protocol layer, how's that edge protection? Well, it's edge protection because you can have a bunch of routes in your IGP, which you can't be attacked from outside. It's an edge protection sort of stuff. So this is where, in service provider security, we think things a little bit different from just like filters on the edge. We do use filters on the edge, but we can also use the protocols itself to protect ourselves. Remote trigger black hole. The number one toolkit we use to actually protect the backbones out there. We got a whole bunch of new people here. How many people here have remote trigger black hole configured in your network today? All right, so some of you should be looking at the tape on the follow-through with this. But this is a technique where I got over here in my NOC, I have a little trigger router, and I get a attack going on in my network. All right, and I'm going to go through and use a one BGP advertisement, and then on the edge of my network, I filter the attack coming in. So this allows me to use BGP to actually drop an attack going towards a destination that's on my network. So if I have a customer who's getting hit with a DOS attack, and that DOS attack is causing collateral damage everywhere in my network, instead of allowing the packets all flow into my network, into my backbone, and hit the customer, I can use a remote trigger black hole and move that customer's advertisement and null zero out to the edge of my network. So I just lessen the intensity of attack by pushing it out. The customer's still under attack, but now my collateral damage is eliminated. All right? Now what's that cost me to do? A static route on every router, a trigger router on the edge. It doesn't cost me a lot to do. So a lot of these techniques, again, are not capital intensive. Because we would create them in an environment where you as engineers and we will work with each other, and you wouldn't have money in your budget for security. So we have to figure out how can we use whatever's in our network today to make the network more secure. And that's where a lot of these techniques came up. This is the next section I'm going to talk about, which is sinkholes. And sinkholes, I'll just get to that section next after we get through it. Another part of the principles is egress packet filtering, TCP 38. Source addresses coming into your network should belong to your customers, nobody else's, right? And there's a bunch of different techniques that you would use to actually filter it. So it's not just unique SRPF or ACLs. There's also IP source verify and a couple other tools out there that you can do. BGP least query, for example. BGP prefix filtering. There's a bunch of techniques you can use today to protect your BGP and your control plane. You don't have to sit there and say, well, I'm waiting for BGP security to come out with a new protocol. Don't wait. There's things you need to do on your network today to help protect your autonomous system to make sure your cable doesn't get trashed. A router in your Ukraine can take out Sweden. Okay, that happened when I was at Juniper. A router in Ukraine took out Sweden, right? With one BGP advertisement, right? Because the filter wasn't actually explicit like it should be explicit, right? That's it happened to be a vulnerability. But, that's the sort of things that you have to, watch out for. Total visibility. If you're a telco in the old school, understanding what's happening to your customers is critical to your business. And this goes of everybody. That same visibility toolset, understanding what's happening to your customer, can be used to understand what's happening from a security standpoint. Right? So total visibility is key. One of the first things they did when I came from Singular Telecom into Cisco Systems is they're getting ready to kill NetFlow. How many people here use NetFlow? Yay! So, you're welcome. That's it. Because I was very, very, I'm a big statistics person. I love net, I was going, you can't stop this. And the reason I gave them Cisco Systems to stop it, being killed, was because of the business necessity that product managers need to understand what was happening to customers. Had nothing to do with security. Had nothing to do with security, but I bet all of you had to look at it for security reasons. but it had nothing to do for security. That's not, wasn't, you know, it was, security came later. Security was like, oh wow, hey, we can use it for security, but the reason it was saved inside Cisco, and the reason why it was integrated with SAP, and the reason why we took it out and did the whole, you know, open source with the C-flow tables and things like that, and different partners, was to keep it, you know, from a product manager perspective. We wanted to know what's going on your network, right? So that's an example, right, of visibility, because it was not just for security standpoint. And then the last item here, and this is a module I'll go through today, is remediating violated customers, right? Your customers that we can, that people give you lots of reports to and say, hey, this customer is infected, violated, right? How do we clean them up? And we've got enough experience out there in the industry to know how to do that. So that's the context on some of the sessions we covered already before we dive into sinkholes. So let's talk about sinkholes. So sinkholes is, how many people have sinkholes configured in their network? A couple of people. After this, you know, one of the things I want you guys to think about is go back and configure sinkholes in your lab, because this is a super powerful Swiss Army knife. The core principle that the term sinkhole came out. It's not a new concept. A sinkhole is a modified shunt. Now, how many people here ever worked on the Cisco AGS Plus router? Oh, all right. Boy, this gets ages. Cisco AGS Plus router had this problem with ACLs. It didn't do ACLs very well. And in certain scenarios, the ACLs would actually knock the thing down the tube. So we came up with this old trick. Ethernet AUI. Remember you guys, Ethernet AUI, right? You take the Ethernet AUI adapter to a coax connector, and you put a T connector on it, right? So you had a little Ethernet segment, which is basically a T connector, coax T connector. And you did a static MAC to that. So basically you had an Ethernet segment that was always on. And then you would forward packets to that. Okay, so that's a shunt. Right? So that was a shunt technique. All right. So so with that shunt technique, right, in 2000 when Code Red came out, or 2001 when Code Red came out, we were trying to figure out how to drop it. So we said, let's take it to shunts. All right. And on these conference calls with a bunch of service providers, I was trying to configure shunts, and people weren't understanding, let's set up a segment on my network to do the same thing. Let's forward Code Red down a shunt, right? Let's flush it down the toilet. Let's sinkhole it. And that's where the term sinkhole came out of. So all we're doing with sinkholes is taking a packet, instead of trying to drop it or do an ACL, we'll forward a packet out of segment. All right? So that's the sinkhole concept, right? So a bunch of these techniques, black hole routers, tar pits, shunts, sonynets, all part of things you can put inside of a sinkhole. And the basics of this, let me go through and say it. Here's my sinkhole. Now, a sinkhole network usually is an Ethernet switch. It just starts with an Ethernet switch. It doesn't have to be a powerful Ethernet switch. It could just be an Ethernet switch that's a spare Ethernet switch connected to a spare port. And you set up the router to point a static MAC to the Ethernet switch. So now you have something I can point to on the interface, right? And so I can forward packets down that Ethernet switch. Now what happens when I forward a packet out the Ethernet switch to nowhere? A CAM is a very good device for dropping a packet, right? Clocks in the frame, clocks it out, all right? Because the whole packet goes into a frame, clock it, boom, packet's dropped. A very lightweight tool for dropping packets. Right? So plug it, that's where you start with the Ethernet switch, because it's very easy to do it. So this sinkhole network over here could basically be an Ethernet switch with a static MAC point up to it. I can send things over that way. So now over here, I got this attack. So this attack is hitting this particular customer. So this host is targeted. So what I'm going to do now is I advertise this, instead of black hole it, instead of stopping it, I'm going to advertise this to the sinkhole network. The packets go into the sinkhole network and then drop. Because the sinkhole, once the packets go in and drop it, it's on Ethernet. Now I can span port it. Now I can put other things on it. I can look at what's going on with the packets. So remote trigger black hole, what I would do on remote trigger black hole is drop it up here but I have no forensics. I don't know what's going on. I don't know if the attack went away or not, because it's all dropped over here. But if I sinkhole it, right, so instead of having the attack drop here, if instead of I have the attack drop in the sinkhole, I can see when the attack goes away. I can look at the source addresses. I can look at the packet types. Is it TCP? Is it UDP? Is it ICMP? Right? Are the ports rotating? Are the ports the same? Right? Are they changing addresses? The source address is spoofed or non-spoofed? I can see all that because if I drop them here, I can't see anything. If I drop it in the sinkhole, I can have devices in there that can actually figure all that stuff out. All right? So this is exactly what we did with Code Red to actually look with it. So this is a tool having a sinkhole in here. By forwarding it over into the sinkhole, it gives me a nice little forensics capability over there and minimize risk with it. So in this case, this is a diagram we talked about with the code or the SQL slammer, because this was used as SQL slammer, where I go out there and then in this case with Slammer on this worm, what we did with Slammer, we told people on your sinkhole, hey, advertise your bogon and dark IP space from here. Now what's dark IP address space? Dark IP address space is that address space that has yet to be lit up on your network. So you get a /19 from Aaron, right? So on that /19, you haven't turned all that /19 on. Now what do? Well, we take the /19 on BGP and we advertise the /19 on these edge routers. So usually what we do on these are my peering routers. I take the /19 and I put lockup routes on my edge. Okay? So I put the lockup route on my edge, and then any packet that comes in goes to null 0 on my lockup route. I can't see it. Right? Well, instead of putting my lockup route on my edge, I put my lockup route here on my sinkhole. Okay? And my lockup route, instead of pointing to null 0, I point it to a static MAC on the Ethernet switch. So now, on that lockup route, anything that's not lit, right, like a worm, comes into that /19, and I can count it. So now I can see all the scans, all the backscatter, coming into my dark IP space. You just turn your network, you just configure your network to be a network telescope. What did it cost you? Okay? This over here is a router you probably already have in your network. I connect it on a port to an Ethernet switch. On the Ethernet switch, I'll plug in spare servers on there. Instead of having my lockup route on my edge, I put my lockup route in the middle of my network on a sinkhole. What did it cost you? I now turn my network into a telescope. I'm now using my dark IP address space to give me forensics about who's scanning my network, what it is scanning it for, right? Looking for worms, looking for malware, looking for activities like that. All right? So it's taking what's already there with it, right? So that's where a sinkhole with it. So we use this in Code Red, and then the worms, backscatter, the telescope sort of work with it. In enterprise networks, we teach people inside big enterprise networks. There's a couple of big enterprise networks who are walking around here, and they advertise their default into a sinkhole, right? They want people to use more specifics, but to put default into there, right? We scale this, and this is an interesting sort of technique. One guy, I did a story of this one guy. So this one guy, I convinced him, he's a big provider, and says, hey, you got to try this technique out, right? This is a great technique. So he tries it out the first time in his lab in St. Louis, and he advertises 96/3. At that time, that was not allocated yet. 96/3 wasn't allocated out there, and he had 2 OC48s going into his lab. Okay, so he configures it to see what's going on with the 96/3. He figured, oh, be safe. Let me configure it and check with the configuration app. Takes down the lab. That means over 2 years, the OC48s dropped in conduction clouds. And he goes like, first he went like, oh, this is interesting. I can see where this technique there is talking about the sinkholes could work. But second thing was, how come there's so much 96/3 traffic on my network? 96/3 isn't advertised on the network yet, and I got all this destination to 96/3 on my network. What the hell is going on my network? right? Surprise. You know, he was surprised with it. Came to find out there was actually some customers that were using 96S3 that shouldn't be using 96S3 and were sending packets out, and it was a big sort of issue he found with it. He then goes through and gets so excited about this that he went ahead and within a year deployed 25 anycast sinkholes across his network on a big nationwide backbone network. Until today, he's got them geographically in strategic pots across the United States, 25 of these sinkholes. And the address that he uses everywhere, each one is the same address for his sinkhole address. And he anycasts it in. And what that allows him to do is to see regional expressions. In other words, he can see which sinkhole does what, right, with it. And he's got the same forensics tools everywhere with it. So it's a pretty interesting system with it. So these things, they work, right? Deployed correctly, you know, you have to put some preparation in there with them, right? You can start it with just one server. Like this one guy, he started with just one server. And he just did an MRTG graph with it. And that's actually from his graphs where he started looking with it. You can use Zebra and FreeBSD, sort of tools on it, the new tools, MRTG tools. What most people do is they take a router as their gateway, they take a small little router, configure an Ethernet switch in here, and they may either configure a static MAC or put a target router in there. It all depends what sort of forensics in there goes with it. And then you put sniffers and analyzers, right? So you can start looking at the span ports and look at the traffic going through there. Sometimes some of these boxes start becoming honey nets with it, so they'll add to it. We can scan the dark IP address. If you can look for scans against dark IP addresses, the bogons, the backscatter from garbage traffics with it. Move there. When Arbor Networks was first working to get out into the market, I mean, you see Arbor all over the place now, but when Arbor was first coming out, they were a minority investment with Cisco. So I was working with them. And a lot of people were scratching their head, how do I figure out what to do with Arbor? And I would teach people, put a sinkhole in, so I'd have them configure a sinkhole, and then we set the Arbor up in here, right? And then we look for dark IP address monitoring, and they produce really nice graphics. And that helped the engineer go to their management and say, see this? This is really cool. And it just, like for instance, Slammer in 2003, Cisco's IT department was evaluating Arbor. And the guys in the IT department, I had them deploy a sinkhole, plug the Arbor in, and Slammer, right, hit Cisco like everybody else. The Arbor alarm went off. The IT department went in there, saw it, shut down the ports, and protected Cisco, right? And then they took the reports from Arbor and took it all the way to John Chambers and showed, here's the reports, and John says, that's a pretty graph. And IT department said, okay, buy Arbor and deploy Arbor everywhere inside the network, right? So the pretty pictures a lot of times are really important, right? So if you have some tool and you're trying to get your management to buy off on it, and you need data to safely show it, like, how do you actually get data sets without your management, it's like a catch-22. I want to get this tool, but to be able to show whether the tool works or not in my network, I have to deploy it in my network. The management won't approve me to deploy it in my network unless they see what it can do. You got this catch-22. How do I get this new tool on my network, right? Sinkhole is a tool where you can go out there and plug a new tool in as a trial evaluation, and you have a bunch of data going across here that has no risk impacting network. So you can probably get management to say, okay, throw it into the sinkhole, there's no risk to my network. Then I can see what the tool can do, right? So this is a nice tool of it. That's actually from that particular incident. Chart with it, with the quarantine part. Backscatter traffic. Backscatter is basically traffic that if I attack your network with a SYN flood, so I'm hitting it with SYN flood, I'm using spoofed addresses in the SYN flood. Those packets are going back. In other words, they head back to the actual source that you're spoofing. Now that source can probably be part of your network. So if you're putting your lockup routes into the sinkhole, right, you basically have creating a mini telescope so you can see who may be spoofing your address space and using that to attack somebody else. Because you'll get that indication, that backscatter indication coming back into your network, right? So you get able to monitor the spoofing part of it. Now, if you're not clear what that means, back in 2001, CADA did this really interesting study where they did a backscatter analysis on an entire /8, right? So the San Diego State Supercomputer Center had a /8, and they put the whole /8 and turned it into one of the first internet telescopes. University of Michigan and San Diego State Supercomputer did the first internet telescope work on backscatter work. Really interesting paper, and this technique is still applicable today. I'll give you an example of it, where this came in. It's not in this slide deck, but I'll put the slide deck up on the website. When Kaminsky, the DNS Kaminsky attack a couple of years ago, oh my goodness, you can spoof and poison DNS, right? And you know, I work at ISC now, right? So, but at the time I was at Juniper, I was going like, wait a minute, something's wrong here. We're missing a piece, and because this looks to be very noisy. And then a colleague of mine who works up in Canada, he tried it in his lab and says, yeah, it's really noisy because you got all this backscatter because I'm spoofing the authority. In other words, if I tried to spoof ISC, right, if I tried to invade ISC and pretend to be ISC and poison ISC using the Kaminsky attack, then ISC, my own network, 1280, would get a whole bunch of backscatter traffic. So all I needed to do to find out if somebody's trying to poison some server somewhere in the world using the Kaminsky attack is to put NetFlow or something in front of my DNS authoritative servers and watch for backscatter traffic. So this backscatter technique, even though, you know, this is 2001, it's still applicable today. So the word that went out for the Kaminsky attack is anybody's really worried about Kaminsky, put NetFlow in front of your authoritative DNS servers and look for backscatter traffic. You see the backscatter traffic, and somebody's trying to poison you. If somebody's trying to poison you, they're trying to pretend to be you somewhere else. That means you got somebody attacking you, not on your network, but attacking somewhere else. So that's some of these techniques. They you know they never go away. So monitoring the spoof traffic. That's you know some of the techniques with it. You know, this is monitoring the spoof ranges with the flashlight 2s. There's a bunch out there. This is doing the lockup routes I talked about before. You know, instead of just having the package drop, you send it over to a sinkhole, right? If it's going over to the backbone router, so worm scattering. So this is just more applicability of using advertising dark IP address space out of it. There, just kind of covered that. And then in any cast sinkholes is, placing them all over the place with the same IP address. And the idea there is that way the backscatter traffic, the sinkhole would go to, like if this is the one I'm trying to sinkhole, it goes to the closest one. Instead of having a central point, you have to go to the closest one. So you see if there's a lot of traffic in that particular sinkhole, then that gives you an indication of that particular region of your network is out there. Now, this is something that was used twice, where a network who had a sinkhole configured was getting their backbone links attacked. In other words, what they were attacking was the point-to-point links on the backbone. Okay, and so at the time it was interesting. Their particular routers that they had did not allow them to throw on a lot of ACLs. Right? So this was a few years ago where the line cards were not allowed good performance on ACLs. So they were stuck in a catch-22. They're being attacked on the backbone link. They needed to do ACLs, but didn't have enough horsepower to do the ACLs. So what do you do here? You have these routing protocols on here, right, that would break. So basically it was knocking down the links with it, right? And the ACLs, I couldn't get them in there, right? So they had a sinkhole configured. And so what we did is basically configured the route advertisements here. So basically we advertise the routes here, okay? And what that would do is if it's a locally generated route here, okay, I'll go over the link here, right? If I'm going transit, I'm okay. But if I'm coming outside the outside world, I'm trying to go to this destination of 2.2 is my attack. I would hit into the router. My red will prefer this route down here to go down to the sinkhole versus actually going over to the sink over here. So essentially, I use the sinkhole as a kind of filter mechanism, because the only thing I needed to have work over here with these two addresses was a route probe. I didn't this traffic over here coming in, I don't need that to go in. The only thing I need going across over here is, as I showed on the last slide, whoops, was the route protocol traffic. Was this guy's. In other words, ping, OSPF, ICE, EGRP, these are the ones that were necessary over here. All right. Transit traffic didn't need to actually see those addresses. Right. Now, they couldn't do unnumbered items. So it's one of those things in the middle of an attack. You don't want to do something like, let me take my point-to-point link and take it to a number. That would have solved the problem. Right. These are some of the things that kind of think through, like core height, because if somebody maps out your network. This was a reaction. This is using the sinkhole as a reaction tool. But if somebody maps out your network and sees all these addresses in there, they can attack it. Right. So core hiding as edge protection. This is part of backbone protection. Is think through. Should customers see those? Some people say, oh yeah, let's allow of customers to see those addresses that are in the trace routes. And some people say, what information does that really give somebody to see those trace routes for? So. And that's our sinkholes. Any questions on sinkholes? IFC 1280 right now, we don't have a sinkhole configured yet. We are getting a sinkhole configured because we got guys who want to deploy honey nets. And so we're going to take our honey net and we'll plug it into a sinkhole. All right? Perfect tool. So that's another nice thing about sinkholes is there's, what's it cost to get a honey net loaded? You download it. You get extra server, right? So again, this is another example where, you're not going out there buying a whole bunch of capital equipment to actually do really significant changes to your network that make your network more secure and to see what's going on with the bad guys and the bad guy operations, right? It's using open source, spare equipment, configurations on your gear, right? And some of these configurations on your gear are the sort of configurations that, are things that are pretty reasonable for doing a rollout plan to get across your network. They're not going to be one of those things where your bosses will say, oh, that's insane. I'm not going to authorize you to configure that across my network. These are pretty rational sort of things to configure, get across on the network. Okay. So let's talk about remediation. There is an internet draft out there called Recommendations for Remediation of Bots and ISP Networks. It's in last call stage, I think, right now, right? Does it help? You haven't been tracking?
I don't remember.
He's one of the co-authors.
No.
Basically, what we had learned over the since around 2005, there's several big providers who are around here, and some of the guys will talk to you about it, who have been doing remediation. In other words, remediation is where, this guy over here gets infected, he's a residential customer, and then I get notified that he's infected, and remediation is the stuff that I let him know somehow. I helped him out to get infected, right? And for years we used a social health, a public health model, kind of like right out of the World Health Organization to say, he's infected, right? I should quarantine him, right? And we came up with certain tools with it. Today, over the last year, we've been shifting and saying, it's not that he's infected, we're saying that he's violated. He's been criminalized. I mean, a criminal has been victimizing this guy, right? Because it's not one of those things where some guys install a malware on his system just to play around with him. Install a malware to steal his identity, to steal his credit card, to steal his bank account. to use his computer in his home to actually attack other people, right? It's like the drug gang moving into your house, attacking other people. So we treat him as not as somebody who's infected. We're treating him as somebody who's been victimized. And if we treat him as somebody who's been victimized, then we have a responsibility to do something, right? So what's going on right now in different countries, the United States is one of them, with the FCC, is we're figuring out what should we do as backbone providers that's cost effective to help out our customers who are being victimized, right? And that's what remediation is all about. This is a collection of recommendations going through an IETF on there, and this is a presentation that kind of walks through all that. So first principle on this is your customers aren't the problem. Your customers are being victimized, right? And if you do this right, if you think through this, the evidence from the people who have been doing this, the providers who have been doing this, Comcast is very loud on this. If you come to the security block, the security session tomorrow afternoon, this time tomorrow afternoon, Comcast will be out there and say, it's actually our customer churn is going down because of this, and the customer report is going up because of the way we notify. Because we treat our customers as being victimized, and we're helping them out, and our customers appreciate us helping them, right? So the general consensus for people who start doing this is that the customers are positively responding to this, right? So and they're helping out with this. The semantic data, here's another data set from the semantic study, and I highly encourage people to go look at this report of the survey they did. But their estimates are showing over 1 million, around the world, 1 million new victims a day. 1 million new victims a day being victimized of people with this malware activity. There's a lot of malware activity going on out there, right? You know, every minute, 820 victims every minute, 14 victims every second, right? So like the way they calculate down. Every day there are twice as many cybercrime victims as new babies born. Right? So there's a lot of cybercrime going out there, people being victimized. So do you think of it that way? So what we're trying to do with remediation is here's usually the malware guy, he does create some malware, he activates it, he does some replication, gets it out there infected, then he victimizes somebody, then we discover it. And we discover the guy's been victimized, this guy's been victimized. Then I discover it, and then we work on eradicating. What we're trying to do with remediation techniques is shortcut this whole thing, where if we are looking for, we can discover it before the guy's been victimized and notify them. So before the credit card gets stolen, before the computer gets used for malicious activities, go out there and start remediating. This is the hope. And there are certain providers out there. CenturyLink is one of them. CenturyLink has talked here at the Denver NANOG during the security block. And I don't know who from CenturyLink is here this time, but they will tell you, here's how we've been doing it at Quest. This Quest now CenturyLink. Here's how we've been doing it for years, and we'll actually walk you through their techniques of how they've been doing it, and basically do the shortcut. They pull in all the forensics data, see it, and put it into the walled garden systems, and able to remediate quite effectively to basically clean up on their network. They have really pretty good cleanup rates across the network, right? So another principle with it is that no one party can clean this up. So in other words, there are people say, oh, the service provider should do all this. You can't. Service providers, all of us in here who are backbone providers, we have a role to play, but we can't do it ourselves. All right? In other words, we have a role to play, but we can't solve the problem. So people say the service provider should do all this and solve the problem. Service providers can't solve the problem. Service providers is just one component of a remediation ecosystem. One piece of the puzzle, right? A necessary piece, a piece that, guidelines are going to say, hey, all you guys should do your role, but operating systems got to do their role, antivirus got to do their role, the customers got to do their role, the application guys got to do their role, everybody's got a part to play. And the service provider's just got a piece of the puzzle, not can't solve the problem. So don't expect to solve the problem. Somebody says, oh, you guys can solve the problem. Say, no, we can't solve the problem. We're just a piece of the puzzle, right? So that's the role with it. The other thing with this is there's no way you can guarantee you can eliminate that one. If your system, I'm sorry, technology, but your system gets infected right? There isn't a tool I can give you to clean it up. You take like DNS changer. We're talking about DNS changer. The big problem we have with DNS changer cleaning up is it is a boot sector infection. It's a boot sector infection that there is no cleanup tool. We haven't got a cleanup tool for it. So what is the recommendation if your system's got DNS changer on it? Reformat. Boot sector reformat. Oh, well, what about my data? Oh yeah, you need to back it up. But you should use the backup set before you got infected. But I'm infected. Right, so now, okay, now you go into the catch-22. How do you clean up your system? Right? So DNS changer is an example, one of those things where the bad guys, get it ingrained in the system that, some of this stuff is getting, really tight. And, there's a warning as you get more and more devices. This thing, yeah, there's a LAN port on this. This is a network device, right? If there was a, one of the sections, those of you on the first section missed on, is cyber criminals, they go after the money. If there was money for me to infect an in-focus projector, right, that I can make money off of it as a cyber criminal, then I would infect it. Now, how do I clean it up then? Right, you go to info, how do I reboot this? How do I do a low-level reformat of it in focus? I don't know, right? And this is the future world we're going into as the home gets wired and wired and wired, and organizations get wired and wired. This guy can plug into the Ethernet, and if it gets infected, or maybe it's running Windows, right? So we saw like Configure getting medical devices, Configure malware, and medical devices. So the funniest thing I ever heard was this thing here for a cleanup. This was a CTO in Hong Kong. And we were talking about what do you do when somebody calls up and they got computer infected with malware? It says, oh, you just tell them to go buy a new computer. We're in Hong Kong. He said, well, what do they do with old computers? Oh, they put it in the market, they reformat the drives, and they sell them. So it's a cost-effective way. You turn in your old computer, they reformat the hard drive, hopefully, and then they go out there and do that. So that was a funny thing that they did with it. So detecting botnets, we can see malware on networks. Like you take the sinkhole techniques, you take NetFlow, take telemetry in your network, you can find it yourself. But you don't, that may take time. If you don't have your network set up to do all that right now, don't worry, okay? Because there's a whole bunch of organizations. So this list over here, which is listed in the draft, the internet draft, all these organizations will give you feeds for free. You want feeds? Like for instance, pass a DNS. Anybody here, pass a DNS. You want to pass a DNS? Come talk to ISC. That's the SIE part. That's our part. Atlas. Hungry. You're part of NSPSec. They give you a report every day. Right? Shadow server. Free. You set it up. You take your network block. You take your autonomous system number. You talk to Shadow server to make sure that you are the owner. So they say, okay, user order, Larry's the owner, says you got the owner, and then Shadow server, who collects a whole bunch of information on malware information, will send you a daily report. Here's the report. Here's who's infected on the network. Okay? So there are a bunch of organizations here. Spam House will tell you who's infected. G-Shield will tell you who's infected. Right? Costs you nothing. Costs you email. Right? Set up a mail list. At ISC, we got a mail list for these reports to go into a mail list. So all our knock guys, they come into a mail list. So that's how we manage it for us. So what did it cost ISC? It cost us an alias. And people sign up for the alias. Right? So again, these guys are already doing the legwork. They're collecting it. Now what do you do with it? So now I get a report in and this guy's infected. Right? So I can get the reports and infected. So what do I do? How do I contact them? Right? Well, basics of business 101. This guy's my customer, right? And if you're my customer, I need to be able to contact you. I need to be able to bill you. I need to be able to call you up, right? I should have your phone number. If you're a mobile provider, you mobile operation, I can SMS. I can SMSs from my mobile provider, right? I get alerts. I'm on Comcast. I get alerts on the screen. right? Pay your bill. Now, right? So this is all normal. Having a tight communication channel to my customer is normal, right? It's a normal part of business operations, right? So security notification alerting violated customers is, I'm already doing this stuff, right? It's the customer loyalty is all there. I'm just looking at how to exploit these little channels. So like an email notification, I can send an email message. So I send you an email, hey, your computer's infected. Oh, wait a minute. He's saying, how do I know it came from ISC? This guy could be spoofing buried, right? So this is where you kind of gotta think things through to be notification. So how does the end user know that I'm not being spoofed? It says, well, you can call this phone number, which is our help desk, or you can use this landing page that we set up. How do you clean up your system, right? I can call you, say, hey, your computer's infected. And he goes like, well, who are you? You're calling me at dinner time. Who are you? He says, well, you know. So you have to have some way to say, please go to this website or check this email or check the postal notification I sent you, right? Because you can send a postal notification, right? Your computer is infected, right? Do an illegal letter. Hey, we saw your computer's infected. We recommend you go to this site and help get cleaned up, right? It's prompting the things to get activation with it. Walled garden notification, right? Go to Starbucks. And I'll point this out. You go to Starbucks. What happens when you go to Starbucks? You have to click yes. That's a walled garden. You know, back in 2005, we were all scratching our head whether this would work or not when Quest was first doing it. We now know it works very well, and everybody's used to it. Your customers are used to doing walled gardens, right? Instant messages. I mean, my kids, you think of how do you get to the teenagers and say your computer's infected? Well, my daughter lives on IM, Google Talk. Okay, well, you have to analyze your customers. How do you get across to them? Maybe you go to a web page and pop up in a chat window and chat with them, right? So as soon as they log in the net, you try to do a pop-up and chat with them, right? SMS messages, web browsers, social media, right? Web browser notifications and social media part of it, right? There's certain places that you probably don't want to try to do notifications, like for instance, internet cafes. Who's infected? Right? It just may not be worth it on internet cafes because people are transiting back and forth in and out. Shared IP addresses, which is basically all your customers because they're all behind NATs, and NATs are all over the place, right? So how do you take care of that part? How many people have how do you remediate a refrigerator? How do you remediate an Xbox? How do you remediate a set-top box? How do you remediate a diabetic monitoring device? This is why we need to start working on the stuff that we need now because it's going to get harder and harder, right? Colleague of mine, Rodney Joffrey, right, works over Newstar. When we were doing the contractor working group, because we're on the contractor working group together, it's a big worm that's still 6 million strong out there on the net. We noticed there was a whole bunch of medical hospitals popping up. And we actually tracked it down and found out there was a whole bunch of medical devices infected with Confector. And still today, there's a whole bunch of medical devices infected with Confector. Right? How do you clean up the medical devices? And then talking to those companies, trying to say, what do you mean malware is on our device? Well, what are you using? We're using Windows. How old Windows? Well, we're using this Windows for like 10 years ago or something like that, right? It's a device. They say, well, why should that matter to us? They have no idea because their focus has been, here's the medical test thing. They're all about the medical test, not the underlying operating system. But yet they get infected as a collateral impact. And also talking to your customers, if you think of them like, okay, you've been victimized, then how I talk to you, law enforcement has a lot of lessons learned. Because if I call you up as a customer and say, hey, you've been victimized, your credit card's be stolen, things like this, we got to help you get your computer cleaned up, can you go to this website and start working on this? If I treat you as a victim, you're not a problem, you're a victim. Then what happens and what the evidence is showing for the people, the operators who are doing this now, is that the customers respond positively. They go like, oh wow, these guys care about me. My provider cares about me. Customer loyalty goes up, right? So there's enough evidence out there that says this sort of action, take action to notify your customers and say you've been victimized and let us help you do something about it, is paying off. It's actually, there's not really a negative to it. And there's not really big cost things with it, because some of the notification techniques are things that don't cost money. But then you run into these things. Customer says, I checked all my computers, my kids' computers, my phone, my tablets, my Xbox, my TiVo, my printers, my furnace, my light controls, my home security system, my healthcare monitoring system, my electric vehicle charging system, my solar panel monitoring system. I packed everything, fixed everything. You're still saying I'm infected malware. That's actually my house. That's everything is wired at my house. There's a lot of things wired at my house, right? And I don't know if I'm infected with malware right now or not, but see, that could be, support team say, hey, have you checked to see if your neighbors are using your wireless? And I have to go like, I have to think about that, because my wireless network is set up with a guest. I got a Mac system with 4 distribution points around my house, and of course my neighbors can pick up and sign up to the green guest network. Right? And so I could get a call from Comcast and say, we got an infected computer on your system, and I'm going to have to check the wireless to find out, is it my neighbor's computer? My neighbor's kid's computer? Is it my neighbor's refrigerator? Connect on my wireless, right? This remediation part can be thick, and this is, you laugh at that, but you talk to some of the guys at Quest who've been doing this for quite a number of years, and they say, they'll get a number of people who are their customers who never knew that their neighbors were actually using them as an access point for the whole community, even if their neighbors had their own Quest account. They just didn't have things configured, and they were using their neighbor's house versus their house. And it's interesting statistics that they would figure out what they do this stuff with it. There's a bunch of solutions out there behind the scenes, and what's interesting right now as we're stepping things up in the industry, how companies like Quest or now CenturyLink and Cox will actually say, please talk to us. Comcast says, please talk to us. So anybody here, as I'm talking about this and saying, I think we need to start thinking about this. And you go talk to your bosses and say, I think we need to think about this. Well, what you can do is email me, and I'll do the email introductions to these other people who are doing it now, who have been doing it for quite a number of years, and say, hey, they like to talk. And you'll be amazed when you start talking to, the CenturyLink, the Cox, the Colt, the British Telecom, these guys who've been doing it for quite a while, how much information you'll get from them. Here's how we did things. Here's the lessons we learned. Here's the techniques we used. We tried this technique, and then we tried this technique. We did this, and we did that. And you go like, wow, this is the report coming with a lot of information. Why? Because it's in our own collective best interest. Because you take CenturyLink, right? And an affected computer on your network is an affected computer that can impact a CenturyLink customer. It's in our collective interest to help each other with these solutions with it, right? So that's why they will help. That's why when I talked about the private-private collaboration making a big difference, that's why it makes a big difference. That's why it makes a big difference to come here. So those of you who are having problems with your management saying, well, I don't know if I should send you to NANOG, you say, this is what I do at NANOG. See, because of NANOG, we're having this conference call with our peers, with these other people out there, figuring these things out. So I need to go to the next NANOG. So I can work on the next thing, right? That's the secret. So if you want to keep on coming back to a NANOG, work with your peers, and then after this session, after when you come back, set up the calls afterwards so your boss will say, this is why I sent you to NANOG, because you're coming back and we're getting the stuff done, right? So that's kind of important with it. And this is just walled gardens. We see them all over the place now, right? So customers are used to it. Now, remediation guidelines, when you tell a customer, says, hey, you're infected, what should you do then? And unfortunately, we only have 3 things. One is self-help, which is probably, 90% of the time is self-help. Say, you're infected, please go to this website and get cleaned up. You're infected, please go to Microsoft/security and get cleaned up. You're infected, please go to Apple/security and get cleaned up. It's self-help is the key thing with it. But you'd be amazed. I mean, you take hire a friend 2 years ago, and their computer, they say, oh, our computer's really slow, so it's probably infected. And it took me 2 days to clean the thing up. I had to re-back it up. I had, basically taken a USB stick with it. There were 6 different pieces of malware on that thing. 6 pieces of malware on that thing, right? Because malware stack up. One bad guy will grab it, and the next bad guy will grab it, and then, they'll stack up on it, right? So self-help is tough. So this is where there's several companies who are teaming up with professional help, right? Go to the store, go to the computer guy store, or go to Best Buy, or sign up with NANOG or Symantec or things like that, right? I use my mom as used to use my mom as a horror story because back in 2004 we were talking about this problem and the cost of this problem at a NANOG here, and BJ Gill, who was at AOL at the time, was up on stage. And we're talking about the problem with it, and my mom, who was an AOL user, got infected, and myself and my brother went around, and so she got on the phone with AOL, spent 10 hours on the phone with AOL cleaning up her computer because of infection. Last year, she spent 6 hours with Symantec because she used Norton antivirus, Symantec antivirus, I don't know. And she spent 6 hours with them on the phone. Didn't cost her anything. I don't know how Symantec's making money off of that now, but see, that's professional help. So you can do partnership and alliances that for professional help, and you can also get into a computer and device. Right? What do you do when you got this stuff out there? Now the consequences of not doing something is the consequences starting to roll in the direction. Everything from the Australia I-code to what's going on in FCC, what's going on in the European Union. What's going on inside China, what's going on around different parts of the world. Civic society, cyber civic society is stepping up and saying, people need to do something. And as the risk starts to get quantified, when people start seeing how much theft is happening, people go like, oh my goodness, something needs to happen. So that's why we do these sessions at NANOG, that's why we do security sessions at NANOG, that's why we have the blue dot this time. It's because we need to do things with it, right? So it's not just the market forces and civil legal actions. There are guidelines going to come across, and then especially when the underwriters come through with it. So homework and asking you guys is, pull up this internet draft, read through it. It's in last call right now. You see something needs to be there. Probably you're at a stage right now. Just say, hey, we can do another internet draft, other guidelines. Other part of the homework on here, as we wrap up tonight. Anybody here who wants to really get involved with doing security techniques, come talk to me. I can plug you into the community, plug you into each other. The wiki that we're going to be setting up here, I'll put this web page up here as we leave so you can see the confluence.org. All these slides that you see are going to be up there in PowerPoint version and PDF version and more. In other words, what we're doing is we're dusting off the work from several years ago. It's a little bit, we didn't have anybody, one person in charge of it, and we're pulling it all together. So Medika Kale, who was here earlier, her and I are actually working to pull together all the service fire security knowledge base we have into one site, one location, right? And we work on this collaboratively, so you're going to see a lot of interesting things with it. The NANOGs, the RICE, the apricots, the SANOGs, groups like that, we're going to be having sessions in it. And we'll work on deploying more, because the more we deploy,